All right, my fellow Euclidean geometrists, here we are on Friday, the 25th of October, and we're going to finish up lesson 3-7. It's on page 130 where we left off yesterday with our kind of part one of this video, and we're talking about perpendicularity, perpendicular lines, and they have an example on page 130. In Braille, it's 130 straight up. It's a little shadow on the drawing here. Let me see if I can fix the lighting for that. So find page 130, and there's a big circle in the midst of the page, and within that circle is inscribed a triangle with some different line segments. So we draw this circle around here. Take a look at the circle. Find your center of your circle. The center is labeled with point T. And then going through the center up to the 12 o'clock position, you get to point E where it touches the edge of the circle. Then going back down through your center T down to the 6 o'clock position, you get to point C. From point C, if you go up to about the 2 o'clock position, you get to point G. And from point G, if you go back to the 12 o'clock position, you're back at point E. Then also go back to the center of your circle, and from T, go through that 2 o'clock position again, and you'll find a line segment going to G. All right, so we're creating several angles here that they're going to discuss in this problem. If you go back above your drawing in Braille and up towards the left in print, it asks to find the measure of angle EGT and the measure of angle TCG. If EG is perpendicular to CG, the measure of angle EGT equals 7x plus 2, and the measure of angle TGC equals 4x. So go back and read that again, and then as you read each angle, go find it on your drawing. So the measure of angle EGT, so go find E, which is at 12 o'clock, and then find G, which is back around that 2 o'clock position, and then go back to center T. So you have that angle EGT, or you could name it TGE. So they're saying the measure of that angle and the measure of angle TGC. Go back up and read the measure of angle TGC. So go find TCG. So you start at T, go down to go to 2 o'clock to G, and then go down to 6 o'clock, C. So you have angle TGC. So you should be putting your brain on noticing that, okay, I have two adjacent angles here because they share a common vertex, G, and they share a common side, TG. I have EGT and TGC. So that GT-TG, that's that common side. So you've got a couple of adjacent angles. So your brain should turn on and go, aha, I could add these together and get something. They're also telling you that EG, so find EG again, E is 12 o'clock, G is at 2 o'clock, line segment EG is perpendicular to line segment CG, so 6 o'clock to 2 o'clock. So those two line segments are coming together and they're creating a perpendicular angle, which means your brain turns on. Perpendicular angles are how many degrees? 90 degrees. So now all of a sudden you're thinking, I've got two adjacent angles. They share a common vertex, a common side, and they're coming together to form a 90-degree angle. So I'm going to add them together to make that 90 degrees. Now they're giving you the measurements in an algebraic expression. So you go back up and read. The measure of angle EGT is 7x plus 2, and the measure of angle TGC is 4x. So you're going to do a little bit of algebra work here, right? So you're going to combine 7x plus 2 plus 4x, and that all has to equal 90. So I'm writing that out on the whiteboard. In Braille, you'd want to be brailing that out. So you notice they have 7x plus 2 plus 4x equals 90. You got to combine like terms. You'd have 7x plus 4x is 11x plus 2 equals 90. We got to get rid of that. We got to neutralize that plus 2. So we're going to subtract 2 from both sides. So 11x plus 2 minus 2 equals 90 minus 2. We end up with 11x equals 88. And then we have to use our division property and divide by 11 on both sides, and x equals 8. That's not the answer, though, is it? They didn't ask what x is. They asked what the measures of the angles were. So then you need to take that 8 value and plug it in, substitute it in to find the measure of your angles. So EGT is 7x plus 2. That's the same as 7 times 8 plus 2. 7 times 8 is 56. 56 plus 2 is 58. And then the measure of angle TGC is 4x. So that would be 4 times 8, which is 32, right? You could also figure out that that's 32 if you recall that they're complementary angles. They add up to 90. So 90 minus 58 is 32. You could do it either by plugging in your answer or just subtracting it from the 90, because that's what they add up to. It takes you through that on the next couple of pages in Braille. It takes you through kind of the step-by-step process and a little bit of proving it. They write out that the measure of angle EGT plus the measure of angle TGC equals 90, and the reason for that is the definition of perpendicular lines. They use the substitution property in the next step, 7x plus 4x equals 90. Then combining like terms, that's a tool in your algebra kit. So the 7x plus 4x, and you get 11x plus 2 equals 90. Then use the subtraction property to undo the addition. 11x plus 2 minus 2 equals 90 minus 2. And simplify with 11x equals 88. Then use the division property of equality and divide both sides by 11 to undo that multiplication. 11x divided by 11 becomes x, and 88 divided by 11 becomes 8 when you simplify it. Then you substitute in, use your substitution property to substitute back in that a to find the measures of the angles. All right? The next several drawings or pages are illustrating. If you get to page 130C in Braille, down at the bottom of your page in print, they do a hands-on geometry lesson on using a compass and a straight edge to draw a line that's perpendicular to a line at a certain point. Now we're going to do this in class in May. We're going to take several days before the end of course exams, and we're going to do a bunch of constructions. But we can at least take a look at the directions here, and the drawings are pretty decent to figure out what they're doing. So the first direction, it says draw a line that contains a point T. So you take your straight edge and you draw a line. It has little arrowheads on the end, and we'll do this on our draftsman. And then they put a point T in the midst of it. You can put the point T anywhere. They chose to put it, it seems, as if it was in the midst of it. They labeled the line L and put it at point T. And if you turn the Braille page, print users, if you go one drawing down, there's an interesting graphic of a compass showing some work that it's doing. So the same line exists on this page with the T point, and it shows that you take the compass and you put it on point T. And the directions say, place the compass at point T, using the same compass settings, draw arcs to the left and the right of T. So what you do is you put your compass on there, and then you spread out the compass to a certain width. It doesn't have to be super wide. And then you draw an arc through your line on the right side, and then you keep the compass on that point and you turn it around and you draw an arc on the left side of your line where it intersects it. So you have two intersection points that you've created with the same measurement from your compass. Then turn the Braille page to the next drawing. And print users, we're looking at the third drawing down on your page. We have this same line with our point T, and now we have those little arc marks going through it at the points that we drew with our compass. And they labeled those points D and K. We still have line L. And the compass, then you take it and you put your little point, one of the points on the intersection, one of the intersection points. So they put this on the intersection D point. And then it says, open the compass to a setting greater than line segment DT. So you have a measurement from D to T. You want your compass to be opened just past T. You want it to be just past T. And then draw an arc above line L. And this is where they did not draw the arc in Braille above line L. It's on the next page, but it kind of bums me out that it's not here in Braille. The next page, they also messed up a little bit in that their T position is not exactly in the middle of this arc, but it shows you putting the compass on the other point on the other side, point K, so to the right of your point T, and keeping the same setting on your compass. You don't move your compass, you keep the same setting. You draw another arc, and then you can feel that it creates an X above point T, and it's not directly above it in this drawing again. The transcribus braillers did not quite know what was happening here, and so didn't pay attention to that it needed to be directly above T. But it does make an X. In the next drawing, you'll see that X is lined up, and it says, use a straight edge to draw ST. In other words, you're connecting the dots. So the intersection of that arc, that X that you made with those arcs, that intersection is a point. They're labeling that S, and then you draw it through your original point T. And when you draw a line between that point and your point T, you've created a line that is exactly perpendicular to the line that you started with. That's how you can do this with just a compass and a straight edge, which is pretty cool. And later you learn and discuss why this is all possible, because we're talking about degrees and midpoints and points on lines and all sorts of stuff. We're bringing it all together. So it's important to kind of look at these drawings and just kind of recognize them and get used to them, because what's going to happen is on an end of course exam, they're going to give you maybe one or two of these drawings, and they're going to say, what are these drawings representing as far as a construction's concerned? And you're going to recognize that the steps are drawing a line that's perpendicular to another line at a given point. Okay, so that takes you through that process. They do a your turn on the next page and say, hey, draw your own line, describe the relationship, construct a line perpendicular to it. So we're going to bypass those. We're also going to bypass 131C. It kind of threw in there an interesting theorem that I want to discuss later. It takes a little more finesse to discuss what's going on here with a line perpendicular to a point on a plane. So let's just go straight to the check your understanding, which is on 131D. And there's some vocabulary in the middle of it and some interesting borders. And then just past halfway down the page, it says check for understanding. So there's a few problems here, number 1 through 7, that we're going to discuss. Number 1 says choose the types of angles that are not formed by two perpendicular lines. Choose the types of angles that are not formed by two perpendicular lines. So this is one of those negative questions. We want to choose which one is not happening. So this is where we look at our choices, vertical, linear, pair, and complementary, and we ask ourselves about each one and whether it's possible or not. So when you have two perpendicular lines, you've got these two lines intersecting at a perpendicular position. You learned earlier that that means it creates 4 90-degree angles. Do you also create vertical angles? Remember, vertical angles are just formed by two intersecting lines, and they're the non-adjacent pairs of angles. Well, of course there's vertical lines with perpendicular lines intersecting because we meet the criteria of two lines intersecting, and you would meet the criteria of having two pairs of non-adjacent angles. So letter A is out. Letter B asks, would you form a linear pair? Well, you got two perpendicular lines intersecting. You got 90, 90, 90, 90 going all the way around your angle, your vertex. You have several sets of linear pairs. 90 and 90 is 180. 90 and 90 is 180. 90 and 90 is 180. So B is out. So by process of elimination, the answer is going to be C, but let's discuss why it's C. It asks, would you form complementary angles? Well, when you have two perpendicular lines intersecting, what are you forming? You're forming right angles. So right angles cannot be complementary. Complementary angles have to add up to 90, not be 90. So that's why you're forming right angles. You could say they're forming supplementary angles, right? 90 and 90 is 180, but there's no way that perpendicular angles would form complementary angles. They can't be perpendicular or they can't be right angles and complementary, because a right angle is just a right angle. Right? So letter C is the choice for number 1. Number 2, write a few sentences explaining why it is impossible for two perpendicular lines to form exactly one right angle. Well, if you have two perpendicular lines intersecting, to get just one right angle, that's not going to happen, right? You're going to have a right angle, and then you go around your circle, around that vertex. You're going to have another right angle, and a third right angle, and a fourth right angle. So you can't just form one right angle. You could form one right angle if you had two perpendicular line segments, but not two perpendicular lines that are going to intersect. Okay? All right. If we move on to number 3, we have to look at a tactile and make our way around a tactile. And I advise when we go around these tactiles that you read about them, but then you go really make yourself familiar with them. So when you read at the top of your tactile on page 132, it says that AB is perpendicular to CD. Line AB is perpendicular to line CD, and line AB is perpendicular to line EF, and determine whether each of the following is true or false. So we're going to make ourselves really familiar with the drawing first, and then go read all the questions. So go to the top left and find point D. Got an arrowhead and point D. D is labeled to the left of it. You go immediately down to through 6 o'clock position. You're going to go through an intersection point, and it has a right angle indicator next to it. So you're immediately going, okay, yep, I was told that AD is going to be perpendicular to something, and there is my square indicating that. And then you follow it all the way down through point C. Point C is labeled to the left of it. So you have line CD or line DC. We can name our lines in reverse order, correct? All right, go back to that intersection point and find that line that it's intersecting with and follow it to the left, and you're going to find point A. Point A is labeled just below the point. Right, point A, and then go immediately right and follow it all the way to the right until you find another point, and that's point B. So there's your line AB. You were told that AB is perpendicular to CD, so sure enough it is. If you go back to that point of intersection where it's perpendicular, they labeled a couple of angles. Angle 1 is in the top left, and angle 2 is in the bottom right. Okay? And your brain should turn on and you should go, oh, those are vertical angles. And those are congruent. And of course they're congruent because it's 90, 90, 90 all the way around. All right. Now, go find the top right. And you're going to find a point F. Follow that point down through the 6 o'clock position to point E. And there's your line EF or FE. And you were told that EF is perpendicular to AB also. Aha! So there's a line of intersection in the midst where it's perpendicular with AB, and there's a little right angle indicator there. And they are also naming that vertex G. From that vertex, from that intersection point, go immediately right and you get back to B. So you have a little line segment there, GB, or a ray, GB. Go back to G and then go at an angle through about the 2 o'clock position, and you go through point H. So you have a ray GH. And that then is cutting up this angle, this right angle FGB, into 2 angles. It doesn't necessarily say it's a bisector. It's just cutting it up. And so we have angle 3 and angle 4. So FGH or HGF is angle 4, and HGB or BGH is angle 3. So that's all the stuff we need to know about our drawing. You make yourself super familiar with it, and then you go read the questions that they're asking of it. So you got to turn the Braille page to find question 3, and it says, measure of angle 1 plus the measure of angle 4 equals 180 degrees. So we go back and we find angle 1. So recall angle 1 was over on the left. Aha, there it is. It's D. It's part of D and A. And they didn't name that vertex, but we do just know that it's the one immediately to the left. We know that's perpendicular, so that's 90. So angle 1 is 90. Then we go find angle 4. Angle 4 was over on the right, and it was a smaller angle, part of one of our right angles here. So it's FGH or HGF is angle 4, and you go, oh, wait a minute. That's an acute angle, isn't it? Well, how can we add 90 and an acute angle together and get 180? We can't, right? The only way we could get 180 is add another 90 to it. So we know, even though we don't know the measure of angle 4, we know it's smaller than 90 degrees, and we know that we can't add 90 and a smaller than 90 angle and get 180. So number 3 is false. Number 4 reads, the measure of angle 1 equals 90. Well, we just solved that one from the last question, didn't we? We went and found angle 1. We realized that, yes, it is 90 because we have this CD perpendicular to AB creating our 4 90-degree angles, a definition of perpendicular lines. So, yep, angle 1 is 90. That's true. Number 5 reads, we read, line segment EF is perpendicular to line segment BG. All right, let's go take a look at that. So EF, we got to find EF. Well, EF was our big line, but now they're just talking about the line segment between E and F. Okay, cool. And is that perpendicular to BG? Well, let's see, here's G, and B goes immediately to the right. Yep, and there's a little square box. So sure enough, BG, which is part of the big line AB, is perpendicular to FE or EF. So that's true. And number 6, that says the measure of angle AGE is less than, be careful with your less than greater, then make sure you read that as less than, is less than the measure of angle 3. All right, so we got to go find AGE. So remember, A is all the way over to the left, and G is our vertex point to the right, and then E is down directly below that. So if you take a look at AGE or EGA, how many degrees is that? It's 90, isn't it? Because we have our little 90-degree angle indicator. We're told that FE is perpendicular to AB, so we know that that's a 90-degree angle. And then we go find angle 3. Oh, yeah, that was that little angle over there on the right. HGB is angle 3. Is that more than AGE? No. AGE is not less than angle 3. Is it 90 is not less than that angle 3. That angle 3 is an acute angle, so we know that it's actually the reverse. Angle 3 is less than AGE. So number 6 is false. And finally, number 7, we get to do a little bit of algebra work. So number 7 says if the measure of angle 3, so that angle that we were just looking at is 2x plus 6, and the measure of angle 4 is 2x, find the measures of angle 3 and 4. So we look at angle 3 and we look at angle 4 and we go, oh, that's right. These two angles together, they're adjacent and they're complementary because they're they make up FGB, that angle there on the top, which we know is a right angle. So we know 3 and 4 have to equal 90 degrees by using that definition of perpendicular lines. So we have the measure of angle 3 plus the measure of angle 4 has to equal 90 degrees. So we use our substitution property and we substitute in the values, the algebraic expressions they gave for each measure. 2x plus 3 is the measure of angle, 2x plus 6 is the measure of angle 3, and 2x is the measure of angle 4. So we plug in 2x, and then that equals 90. So we've used our substitution property. Now we use combining like terms to clean this up. 2x plus 6 plus 2x is 4x plus 6, and that equals 90. And then we have to use our subtraction to negate the plus 6. So we have 4x plus 6 minus 6 equals 90 minus 6. So we have 4x equals 84 when we simplify, and then we use our division property and divide by 4 on both sides. We have x equals 21. Now that's not the answer, is it? 21 is x, so we got to plug that in for the measures of each one of those angles so we can answer the question about what is the measures of the angles. So the measure of angle 3 was 2x plus 6. We're going to plug in 21, 2 times 21 plus 6, and that equals 42 plus 6, which is 48. Then we'd say the measure of angle 4 equals 2x. We substitute in our x value, and we have 2 times 21, and the measure of angle 4 is 42. You could also take 90 minus 48 and get 42. So there you've done some algebra work with that drawing also. So that's all I'm going to do for this particular video. What I would suggest is that you work on problems number 8 through 25 on the next several pages. You're going to have 3 different tactiles to make your way around. Try to figure them all out, where the different angles are and the different points are. Make yourself very familiar with what they've given you about perpendicular lines and midpoints, and then answer the true or false questions. They're also going to have some basic algebra that you need to do to a couple of questions, just like we just did now, and you can do that. So for extra practice, I would suggest you do page 132, number 8 through 25, and really take your time with those graphics and those tactiles so that you can make your way around them and solve those questions. All right, that's all for 3-7. I believe chapter 3 is done, and we will head on into the review and a chapter test next week. Have a good one.